Yeah.
Hi, Shah. It's my pleasure to be here with you today.
Perfect.
My name is Assis, and I will show you some experiments in electricity.
Perfect.
This is the oldest experiment in the history of electricity. It's
Okay.
called the Amber effect.
Amber effect.
I have a straw, plastic straw,
Right.
paper napkin.
Okay.
I just rub it here
To charge it.
to charge, and then I attract some bits of paper.
Perfect.
Usually in Greece they made it with amber,
Mm-hmm.
but now we have plastic that's much easier, but it is the same thing.
Right.
Now, this is the oldest instrument created by man to study electricity. It was created by Gilbert, 1600.
Right.
So this is cork, just a pin to
A
support,
small pin. Okay.
and this is paper fastener,
Yeah.
which
Right.
with
Right.
two legs. I
Okay.
just open it, and with a hammer I make a small,
a small
so that it
indentation.
does not slip.
Okay.
Okay, so
And it's free to rotate.
yeah, so
Okay.
it's free to rotate, exactly. Now I will rub it once more, so it is at rest, okay?
Okay.
And I just approach it. I don't,
Wow. This is amazing.
and I can make it turn in the other way, okay? You see?
Oh, let's touch it now.
Yes, but it doesn't matter. It can touch,
Right.
no problem. It goes very fast.
Wow. So the mechanism is like when you make it near, there's a polarization
Yes,
happening,
exactly.
and similar opposite charge attracts, and
yes,
therefore
yes.
the wheel like follows the
Yes,
thing.
and I can even
Interesting.
let it touch, you see? No problem. It continues being attracted.
But wait,
But
when you touch it,
no problem. It continues to be attracted. No, but I don't need to touch to make it move.
right, right,
Okay. So this is called versorium.
okay,
It's just like a compass needle, but it's not magnetized.
okay,
Okay. So and this experiment is similar to this one, but this instrument is more sensitive
yeah,
because you don't need to go against gravity.
and yeah, right,
So Gilbert did utilize this instrument to find other materials which behave like amber.
okay,
Because, for instance, you can take create here diamond. Let's suppose sometimes you can rub it here and you don't attract papers.
Yeah.
But when you get it close, it spins
it means right,
because you don't need to go against gravity. And so he found different materials which behave like amber,
right.
and he called them electric.
Oh,
Because
It-
the
it-
word electric means amber in Greek.
right,
So he called every material which attracts like amber electric. So
Okay.
that's the origin of our name, electricity, electrostatics,
Interesting,
electricity.
interesting,
So this is similar, just more sensitive
more sensitive.
and very beautiful. And we can make it with paper, plastic, any material. It doesn't need to be metal. This one is metal, but it doesn't need to be. Now I will show to you something new.
Okay, go ahead.
So this something new is called an electric pendulum.
Electric pendulum.
Yes, so this is just a pendulum. The essence of the instrument is this
Small wire.
the
It's a thread.
string, this small thread, and a paper disc.
Right,
This is a straw, plastic straw.
right.
This is another paper fastener, another straw.
Okay.
So we can dismount it, and this is just a plastic
To the support, right. With the charge.
cup of coffee.
Okay.
This is clay,
Okay.
and this is another paper fastener, just like this
It's
one.
another one, right.
This is just to support, but the essence of the instrument is here.
Okay.
And so I will just put it here. It's very simple, but very
Yeah.
sensitive. Put it here, okay. And now I put it here. Okay.
Okay.
So this is a paper just like this one. So I will attract it. And again, it is supported, so the gravity doesn't play a role here. So it's more sensitive then
Then the other, yeah.
the other one. So I do it the same. I will come here from this side,
Yeah, it
and it
filtered.
comes towards me.
Yeah.
Now I come to the other side, and it also comes towards me.
Right.
You see?
Yeah. So it's the same mechanism as before.
All the same, all the same. And for 2,500 years, this is what everyone saw.
Okay.
Electricity is essentially only amber and only attraction. So that was a curiosity, but nothing else than that, for 2,500 years, until they discovered something new. And I will show two very important things.
Okay.
One is this one, you see? So I will repeat. It is attracting, you see? Or the other way around. It is attracting, okay?
Yeah.
Now I will show something special.
Okay. Ooh. Wait. So it jumps and then start repelling.
It
Repelling? No.
began to repel, yes, you see? And it
But
repels
when
very strongly.
So it's confusing a little bit. So before, when you were doing with that thing, when you touched it, it still used to follow it. Didn't
Yes.
repel. And here,
Yes.
it's
It's something new,
right.
quite new. So for the first time, we are seeing repulsion.
Yes.
For 2,500 years, no one saw that.
Okay.
It may seem simple, but
Well,
no
nobody
one
observed
saw
it.
it.
Yeah.
So I will repeat again, okay? So I come here, and it is being attracted.
And you touch it? No?
I don't let it touch, you see?
Yeah.
If I let it touch, something new happens. Okay,
Push it,
that is the secret, to let it touch. So now I will let it touch. So before just repeating, it is attracting, okay?
Yeah.
But I don't let it touch. Now I will let it touch. Oops.
Oh, this is amazing.
Immediately
Right. So maybe,
it is repelled.
Yes. So because now they have the same charge.
Yes,
And
there was a transfer of charge.
And so it's quite very quick, right?
Very quick, instantaneous.
Yes.
And you see, the guy who discovered this, his name is Dufay, a French guy.
Okay.
And he called it a mechanism of attraction, contact, and repulsion.
Okay.
ACR mechanism, attraction, contact, and repulsion. So after that, it will always be repelling. But I can begin again.
Yeah.
I just need to touch here.
Yeah.
If I just touch it here,
It's discharge.
it discharges and I can begin again. You see, it comes and then it touches and it is repelled. If I just touch it with my hand, I can come and begin again. You see? And then
Yeah, it's very beautiful.
it's beautiful. But you see, Shah, with this paper, the same thing happens. But why no one did saw it before? Because sometimes the paper touches and it is repelled. But as it falls to the ground,
because, and then people
thought it
interpreted
is
the gravity.
because of
Okay.
gravity.
Oh, hey, that.
It's very subtle, but no one saw repulsion for 2,500 years.
And to come up with this kind of geometry is not
Yes.
easy. So maybe they just say, okay,
Yes,
it's,
it's,
okay.
but you see, Isaac Newton didn't know about this.
Yeah, okay, this is amazing.
For 2,000, the electricity is very old. That's come from Plato, the philosopher in Greece. But
Yeah.
no one saw it. It's just fascinating. So here we have some new things. And very beautiful because very simple to build. And the effect is wonderful because it comes and you chase it and it goes away.
Yes.
Very,
And you can even measure how strong the repulsion is because like
the,
it pushes.
the more you charge, the
Yeah.
greater will be the repulsion and so on, you see. If I do it like that, then we can
Interesting.
begin again.
Interesting. It's amazing.
Now I will show you a third instrument.
Yes,
so
please.
this one is one element, only the head, which spins. This instrument here has two elements, the paper disc and the thread. The
Yeah.
thread is crucial.
Yeah. Okay.
It's not any thread. It cannot be a cotton thread, for instance.
Okay. So it should be insulator.
That is, yes, that will come to that later on. This is another kind of versorium. This one is made of plastic, just a plastic made like a hat, and a pin fixed.
Yeah.
And it also supported here.
You put. Okay, this is so free now.
Yeah, so they're very similar to that, but this is made of plastic, you see. But I can also do the same kind of experiments. And here I have a small piece of paper, which I can put it here, and so there are different ways of doing this versorium. Now I will show to you a third instrument, and the most important of them all, which is this here.
Yeah.
So once more, this is the support.
Okay.
Okay, just the support. The instrument is here.
Okay.
It has three components.
Okay.
The straw, cardboard, and this strip here.
Okay.
This strip, this is made of kite paper.
Okay. Okay.
But this, in Brazil, we utilize this to wrap candies.
Right. We have it.
And we buy it, they come already with this strip.
Yes.
We buy it for 50 cents, 100 sheets of paper like that.
Can it be like the baking papers?
Yes, that's possible, yes. But it is the same paper that we utilize to kites in the sky and so on. And so this is this strip here.
Okay, one strip.
So it's very light, and we just glue it on top. But
Okay.
below it is free to move.
Okay.
This instrument is called electroscope.
Electroscope.
Yes, like an indicator of electricity or something like that. What is the experiment? The first one is I will charge it.
Okay.
So I rub it here, and then I scratch it on the cardboard.
To make the charge transfer.
Yes, to make charge transfer. I do it a few times, and then the strip begins to go up, you see?
Since they have the same charges, now then again refresh.
You see? I can hold it in my hand.
Okay. Yes.
I can hold it.
Okay, there is a...
Just like magic.
Yes.
But this is not yet the main experiment. The main experiment comes now. I have another straw here, which I didn't do anything with it. I will just let it here.
Okay.
What happened to the strip? Nothing.
Nothing.
It remains there. Okay? Now, do we have a piece of metal here? A wire or...
Piece of metal. Maybe my glasses, but it's...
No, maybe this one here.
Okay.
I think I don't...
I have a spoon. That
Yes, a spoon, perfect.
Yeah, there is
Okay, so now, we first touch it with plastic.
Okay.
Now I have a metal spoon in my hand.
Yeah.
And I will touch it here.
It's a conductor.
Yes.
So the charge flow to your hand. And
so this instrument is amazing, because with this instrument we can distinguish insulators like plastic and conductors like metal.
With a simple thing.
Very simple thing.
Interesting.
And it is immediate.
So if I put water into that tube,
yes,
and then put it there, would the charge flow?
Now I will not give you the answer. I will let you to do the experiments. Okay?
Perfect. Isn't it nice?
And I ask any colleague of yours who is watching this video, I will repeat the experiment, but I want you to build one.
Okay.
And a pendulum, a versorium, and an electroscope. and then you will make a guess.
Okay.
We'll take a sheet of paper and you write down in one column insulator and in the other conductor.
Okay.
By insulator, we will write plastic.
Okay.
By conductor, metal. And then you will make a guess what happens if, instead of touching with a plastic or a metal, what happens if I touch with rubber?
With rubber.
What happens if I touch with glass? What happens if I touch with styrofoam? What happens if I touch with cotton? What happens if I touch it with wood? What happens if I touch that with...
So I can literally check any material.
Any material. But before you make the experiment, I want you and anyone who is watching to make a guess.
Okay, before
this is crucial. This is crucial.
Okay, okay.
Make the just make a guess. What do you think? Rubber, is it insulator or conductor? If you think it is insulator, you write down in the column of insulator. If you think it is a conductor, you write down in the conductor column. Okay? And I promise you, Shah, that you'll be surprised.
Okay.
Some materials that you think they are
they're
conductors, they will be insulators. Some that you think that they are insulators, they will be conductors.
Conductor. Okay.
But I won't tell you beforehand.
Okay. Okay.
Because I want you first to do.
To build this, it's very
instrument.
simple to build. Yeah.
And the second is to make a guess. After you make a guess and make the experiment, we talk again.
Okay.
And maybe you can even make a second video.
Perfect.
But after that,
Okay.
only make a guess first. You don't need to tell me what were your guesses, but only make the experiments, and then we talk again. And the same with your colleague. So I will repeat the experiment. This is straw.
Yeah.
Do it here, please. Just let it be supported here, as long as
So
you
it
wish.
doesn't. Yes.
You can even
So
you can even hold it so that people can see that it is touching there.
Okay.
Hold it like that here. Support, yes. So that people can see that it is touching there, okay? Now do it with a metal spoon.
Okay. Wow.
Immediately it goes down.
It's very instant.
And it goes down and it does not come out
Exactly.
again, okay? This is very, in textbooks, we learn about the gold leaf electroscope with two legs of gold.
Okay.
Normally they are inside a sphere of glass.
Yeah.
And for instance, I always thought that it was in vacuum. And I always, when we hear about gold leaf electroscope, it should be very expensive because we hear the word gold.
Yeah.
So maybe it is made in NASA or, but you see, here it costs nothing.
Nothing.
And it is
nothing.
extremely
Just
sensitive.
2 straws and
And very sensitive.
Well, at least in high schools,
Yes.
teachers should perform these
Everywhere in the world.
Yeah.
In Pakistan, in Brazil,
I would
everywhere.
definitely do it. to
Yes,
children.
you need to share that with your colleagues at home,
Yeah.
so that this can be. And
Perfect.
just to finish, those who wish to give a look, we have a book on these experiments. All these experiments, they are in this book.
And it's written by you and
Written by me,
Assist.
and it is free PDF in my homepage. Just look for my name or the title. We will end up in my homepage, and you can download the whole book for free in PDF.
Interesting.
The experimental and historical foundations of electricity.
And these are basically the
And I have here maybe 300 experiments. I just showed 3 of
300?
them here. It's
Wow,
a great number.
I think it's a big...
And not only the experiments, but I quote here who made that for the first time, and I quote his words of this scientist.
And what they like...
What they did, how they did come to this idea. From the Amber effect, until the electroscope, pendulum, versorium, Gilbert, Dufay, Gray.
Yeah.
So anyone can download it completely
Yeah.
into my homepage.
We have some a foundation. It's called Maths Volunteer Foundation,
Okay.
and we can maybe choose like some experiments from this book and go to high schools.
Yes, sure,
and
sure.
do it for children.
Yes, sure.
I think it's gonna be.
I would be very happy if this would be done. You can utilize everything from the book. You don't need to ask permission for nothing. Just do it, go ahead, and I will be very happy.
Perfect.
And if someone wishes, through you, can get in touch with me. Okay, Shah?
Thank you.
My pleasure.
Thank you very much for doing all this.
Okay,
Yeah.
thank you very much.